here we have plus 3q. So we have it's a couple of charges. 3q. So let me draw that. It said you have a 3q located at minus d. So let's just say that this is the y-axis and this is the x-axis, right? X, y, and you have 3q located at minus d. So this is the 3q, and this is d here, minus d, and minus q located at d. So this is d, and this is minus q, and it wants the expression at 0 y0. So so that means that you're somewhere on the y-axis. Like, let's just say somewhere here. You there? So yeah, so that means we have a couple of charges. So let's work with the 3q. So this is your separation vector, which is that. Yeah. And this will, of course, give you, so the electric field, this will go away from a positive charge. So generally speaking, Coulomb's law says the electric field is 1 over 4 pi epsilon integral of q, right, over pi squared, separation vector squared, right, times unit, and this is going to be some direction which will be determined, right? So in this case, your separation vector, if this is a y, right? So your separation vector, you can use the distance formula. So it's x, so it's 0 minus d square. You agree? Because the x is minus d, plus 0 squared. No, wait, 0 minus y squared. Sorry, y minus 0 squared. And the third one is 0 squared, because there's no z on both of them. So this will be d squared plus y squared square root, right? And let's say that this angle here is alpha. So the direction of this electric field vector will be, there's two components, whatever the magnitude is, times cosine alpha in the x, plus sine alpha in the y, right? Okay, so now just plug them in. So so what we're gonna get is plug them into the Coulomb's law. Yeah. So you're gonna get E equals 1 over 4 pi epsilon. Wait, this is here supposed to be, yeah, this guy here is just this, yeah, the unit vector of that guy. Yeah, so so yeah, now just plug them in. So you will get by the way, we don't need an integral here because this is just a point charge. There's no need for an integral, yeah. So q is 3q over that squared is just d squared plus y squared, yeah. And look, I could be yeah, the cosine alpha will just be y over, right, or I mean d over from the triangle, the separation vector, which is d squared plus y squared square root, and the I, and then the sign is just y over that.
Only ask for y.
And the j plus 0 in the k. It's asking for the y?
Yeah, that's what I got for the y.
No, it says find a general expression.
But for the electric field. For the electric field in the y direction.
No. It says 4 points on the y-axis.
Yeah, but it says for the field E of 0, y 0.
That's just the location of the point. You still have to find the whole thing. So that means E, the final answer will be 3q over 4 pi epsilon. You can FOIL that d squared plus y squared. So you will get d over d squared plus y squared to the 3/2 and the I plus y over d squared plus y squared to the 3/2 and the j. That's the first one. We haven't found the second one yet. There's another charge. So this guy here is the first E. So let's go to the second charge. So now if you draw the second charge, so from the same point here, this is a negative charge, so the electric field will go towards it. Yeah, so it's going to go down like this. So this here was E1, and now we're going to do the same exact thing for E2, except that E2 will have a negative y. Yeah, so if this angle here is phi, this angle here will be phi. And yeah, we can, since we kind of did the in-depth work, we can just summarize here. So E2 will be 1 over 4 pi epsilon times Q, right? And then the sine phi, first cosine phi. So so here in this case, let's just write it 1 over pi squared psi squared over psi. So what's psi in this case? The same thing, yeah? Not going to make a difference. It's d squared plus y squared square root. And so E2 will be q over 4 pi epsilon, right? 1 over d squared plus y squared. Cosine phi will get you d over the separation vector. D over the separation vector in the I minus y over the separation vector in the j. Sorry, square root of the separation. Square root of the, because it's squared. So now you can just factor this out. So you get q over 4 pi epsilon d squared plus y squared to the 3/2. And you have inside left di minus yj plus 0k. And on top here, I could have factored out this as well. Let me factor it out. Or I could just drag it here outside. I'm not going to be able to fit it. Let me just rewrite it. 4, let's do it in red. 4 pi epsilon d squared plus y squared to the 3 over 2, right? Di plus yj plus 0k. Okay, so now E total, yeah, E net will be E1 plus E2. So you could add them up. You have 3QD plus QD, so that will get you 4QD over 4 pi epsilon. Let's leave the D in the parentheses, yeah. Actually, no, let's just do it here. 3QD 4 pi epsilon D squared plus Y squared to the 3 halves and the I, and now we add the J with the J, so you have 3QY minus QY, so what's that? 2QY plus 2QY over 4 pi epsilon. Let me tell you what, actually, yeah, let me factor out the 4 pi epsilon d squared over y squared. Isn't it better? So just move this here to the right. And move this here. Because I just want to factor these out, yeah? 4Q, I could also factor out the Q's, yeah? So Q, and then I would get 4D plus 2Y, 4DI plus 2YJ plus 0K. Move this slightly left. Okay. So this would be the E net. So this is the expression for the electric field for points on the y-axis. Of course, it has a y dependence because of this. So that's what the question is asking for. Because did we add this right? Yeah, we have D 3QD and we have QD, so that's 4QD. Okay, and then the y component is 3QY minus QY, so 2QY. Yeah, and then there's no Z. And of course, you know, you could figure out the angle will depend on the y, and you could figure out the magnitude. You know, just square both components, add them, take the square root. But he said just figure out the expression for the electric field. So that would be the expression of the electric field. Yeah. Is that what you got for ENAT?
Well, I just did the y. That's basically what I did. I did the charge times the sign for the y times the sign over the separation vector square.
Yeah. And by the way, the unit vector separation vector that we were talking about all along is just this guy, just so you know. That's the first one, which was in this first formula. This was yeah, pi 1. And then the second one was this guy here. Wait, it goes from the point. Yeah. So it's basically, actually it's this one. It goes, it's at the point. So yeah, so it's this. Yeah. Okay, and then notice in part C, he says, so this was all part B. In part C, which is actually interesting, he says, now let the point get very far away, meaning y is much, much, much greater than d. So you are at an infinite distance from those charges, right? And then he wants you to figure this out. So what we could do here, we could do a power series approximation. Right?
I was thinking just plug into the actually, yeah. Well, I was thinking just for the y component like this.
If y is much greater than d, that just means that d over y is much, much, much less than 1. And here what you could do, you can go to this term here and do a power series approximation, because E naught would just become q over 4 pi epsilon, yeah, d squared plus y squared to the minus 3 over 2. Now what I could do, there's many ways to do this, but the easiest way is factor out from this. You want d over y, so factor out y squared. So you get d squared over y squared plus 1. So 1 plus d squared over y squared if you factor out y squared. Yeah, and this is all raised to the minus 3 over 2. And let's not forget the right hand side of this. We'll come back to the right hand side, which is this guy here. Right. Now I'll come back to the rest. What's important is this. So we get, so let me solve this here by itself. So we get y squared to the y squared times 1 plus d squared over y squared, and the whole thing is raised to the minus 3/2. So I'm just taking this piece and I'll see what that gets me. So that becomes y to the minus 3, because you multiply squared times minus 3/2, you get minus 3. 1 plus d squared over y squared, right, to the minus 3 over 2. Now, since d squared over y squared is much, much, much less than 1, you could do a power series. You could do a power series expansion on this. This is a binomial series. So if you remember, this becomes y to the minus 3. It's 1 plus kx, 1 minus 3/2 times d squared over y squared. So the power series formula goes 1 plus kx plus k over 2 factorial x squared plus k times, wait, this is k times k minus 1 x squared k minus 1 k minus 2 over 3 factorial x cubed, etc., etc., etc. Okay, it's a series.
Is that a gamma function?
Ignore the no, it's not a gamma function. It's a binomial series. It's the definition of the binomial series.
So the
This is in your calculus class.
so if d squared if d is much smaller than y,
Wait.
I squared it.
This is k minus 2x cubed over 3 factorial, etc., etc., etc. Yeah, so in this case, this is our k. Yeah, so so then, you know, 1 plus kx, so k is minus 3/2, and this guy here is your x. And so the next term will be let me continue in blue. So minus 3/2, right, times minus 3/2 minus 1, which becomes minus 5/2, because it's k, next term is k minus 1, times 1 over 2 factorial, which is 2, d squared over y squared squared. And I could keep going on, but the reason I can stop is because I can ignore these higher order terms. Yeah. And so then this becomes, if I just consider the first two terms, so this becomes 1 minus 3d squared over y to the 5. Because, oh wait, 1 over y cubed. One over y cubed minus 3d squared over y to the 5. Okay, so this thing, this power series expansion gave me this. So now I can go back to the electric field, and I could replace that with what I've got. So we would get E equals 1 over 4 pi epsilon, yeah, times 1 over y cubed minus 3d squared over y to the 5, which I can basically ignore now, because you know, d over y is a lot less than 1, so I can safely say that this goes to 0. And then the remaining terms is, now since y is much larger than d, I can just ignore the x component of the electric field at very large distances, because y is so huge compared to d. So that's just times 2yj. And notice here something interesting happens. Y cancels with y, and you get 2. Oh, I forgot the q here somewhere. Yeah, there's a q somewhere. Yeah, there's a q somewhere. So this is q. So I get 2q over 4 pi epsilon y squared j. Now, does that make sense? It makes absolute sense, because this again shows that when you're very far away from a point charge, the electric field decreases, is inversely proportional to the square of the distance from the point, because now those 2 points just look like one point when you're so far away on the x-axis. Since the distance between them is so negligible, it takes you back to the basic electric field ratio, you know, the inverse the inverse proportionality between the electric field and the distance shows up in this formula again. 1 over r squared. It drops down as 1 over r squared of the distance, which is exactly what this is showing once you do the expansion. The d squared over y to the 5?
Yeah.
I mean, because the assumption, remember, is d over y is much less than 1.
Oh, right. Oh, yeah.
Yeah, and I'm getting here a series, and keep in mind that this series converges when g over y is much less than 1. This is the radius of convergence of the series. This is only true when d over y is much less than 1. This is the ratio of my series. Absolute value of y. Because I could also be in the negative y direction. Yeah. Yeah, so basically the main idea is that when you're so far away from those point charges on the y-axis, the field is the same as if it were the sum of those two charges. 3q minus q is 2q. The sum of these two charges, 2q, at a distance r away. That here is kind of the basic idea, and it does conform to the basic Coulomb's law that says that the electric field decreases to the 1 over distance squared from the charge.